video, let us see what is refraction and laws of refraction. When light is passing from one medium to another medium, there is a bending. This bending is known as refraction. So refraction is the bending of light when it travels from one medium to another medium. Here light is traveling from a medium whose refractive index is N1 to a medium with a refractive index N2. So here light is traveling from a rarer medium to denser medium. So there is a bending towards the normal. So this is the incident ray. This is the refracted ray. Then angle between the incident ray and normal at the point of incidence is called angle of incidence. And this is the angle of refraction, angle between the refracted ray and normal. When light is entering from this medium to this medium, there is a bending. Instead of going straight, it is bent towards the normal. If it is traveling from a rarer medium to denser medium, here light is traveling from a denser medium to rarer medium. So you can see it is deviated away from the normal. In this case, angle of refraction is more than the angle of incidence. Now let us see the laws of refraction. First law, incident ray, refracted ray and normal at the point of incidence lie in the same plane. That's the first law. Now let us see the second law, is also known as Snell's law. Snell's law states that the ratio of the sine of the angle of incidence in the first medium to the sine of angle of refraction in the second medium is equal to the ratio of the refractive index of the second medium to the refractive index of the first medium. Refractive index is the ratio of the velocity of light in air or vacuum to the velocity of light in the medium. For example, refractive index of glass. Velocity of light in air or vacuum is 3 into 10 raised to 8. Velocity of light in the medium. Suppose it is glass, then refractive velocity of light in glass is 2 into 10 raised to 8. So it will be 1.5. So refractive index of glass is 1.5. Then because of refraction, there will be a deviation. So this is the incident ray. Instead of going in this direction, it has gone in this direction after refraction. So this is the angle of deviation. Then angle of incidence. So this is also angle of incidence because vertically opposite angles. Then our aim is to get the angle of deviation. So from this I, we have to minus this R. So deviation is I minus R. Here light is traveling from rarer medium to denser medium. So the light is bent towards the normal. Here I is more than R. So I minus R. In this case, light is traveling from denser medium to rarer medium. So N1 is greater than N2. Here denser medium to rarer medium. In this case, rarer medium to denser medium. So N1 is lesser than N2. In this case, N1 is greater than N2. So here you can see angle of refraction is more than the angle of incidence. It's deviated away from the normal. So this is the deviation, angle of deviation. So this is the initial direction of the light. After the refraction, light is going in this direction. So this is the angle of deviation. So it is deviation is R minus I. In the first case I minus R, now it is R minus I. At any refracting surface, a part of the light will be reflected, another part will be refracted. So this is what's called a simultaneous reflection and refraction. Principle of reversibility. Here light is falling at this point, so this is the incident ray. After the reflection, it is passing along this direction. Now suppose we reverse the direction. If light is coming in this direction, it will go along this direction. So if the direction of travel is reversed, it will follow exactly the same path. So in this case, this is the incident ray. This is the refracted ray. Suppose we reverse the direction, then light will follow exactly the same path. So that's what's principle of reversibility. Principle of reversibility states that light will follow exactly the same path if the direction of travel is reversed. Now let us see what is relative refractive index. When light is traveling from one medium to another medium, there is a bending, and you have seen Snell's law. Sin I by sin r is equal to n2 by n1. So n2 is the refractive index of the second medium, n1 is the refractive index of the first medium. Now n2 by n1 is known as refractive index of the second medium with respect to the first medium. Now let us see inverse rule. Here refractive index of the first medium with respect to the second medium. Then instead of n2 by n1, now it is n1 by n2. So that can be written as 1 by n2 by n1. n1 by n2 can be written as 1 by n2 by n1. So n2 by n1, you know, it is refractive index of the second medium with respect to the first medium. So for this we can write n21. So now n12, that is refractive index of the first medium with respect to the second medium, is equal to the reciprocal of the refractive index of the second medium with respect to the first medium. Now let us see chain rule. Refractive index of the third medium with respect to the second medium, that can be written as n31. That is refractive index of the third medium with respect to the first medium multiplied by refractive index of the first medium with respect to the second medium. So now refractive index of the third medium with respect to the second medium, that means n3 by n2. So it can be written as n3 by n1 into n1 by n2. This n1 will get cancelled, so n3 by n2. So this is what's called the chain rule. Thank you for watching.